Exponential growth and decay is something that confuses me because having a derivative equals something with the original function on the other side always throws me off. They're called differential equations, but what isn't nowadays? And I think I just need to break it down really quickly, and hopefully you can stay with me. I notice that k here is not part of our derivative. It's just some number. It's not like an x value. It's a constant value. And let's say that it's a positive value for this. Like, let's say it's a 0.5. I'm going to say k equals 0.5. Maybe I'll just write it over here like this. And derivatives tell us how much something is changing at that exact moment. So for now, I think what I'll do is I'll pick a moment in time, and we'll see what's happening with it. Say I have a population of y equals 100 people. I'm going to plug that right in here, and I'm going to use that k value here of 0.5. And what's 0.5 times 100? Obviously, that's 50. And what that tells us is the change in population right now is plus 50. So at the next step in time, it's going to be 150. That's how the derivative equations work, right? They tell you what happens at the next step in time because you know the slope. What if I do it again? If I put 150 back into here and I use my growth rate of 0.5, the next thing I'm going to find is 225. And after that, it's going to be like 337. It's a big number quickly. So what you see is growth rate is doing this, exponential increase. Even though my k value is a decimal, that's an exponential increase. Let's try the eraser today. I haven't done that yet. What do you think? I think I prefer to just select and delete stuff. We'll try it. What if I set k to negative? Negative 0.5. Well, we start with a population of 100 for y value. And we times by negative 0.5, right? What would it become? Negative 50. So we update the value by that much because that's how much we change by. 50 off of 100 is 50. Are you getting it yet? Now if I take 50 and put it in, and I times by negative 0.5, what do I get? Negative 25. If I take 25 off of 50, it becomes 25. And you can see what it's going to do here. It's not going to become negative. It's going to keep cutting in half. So exponential decay looks like this. It's changing by less each time, but it is always shrinking. That's really all they want you to understand when it comes to this kind of differential equation. And there's actually something we already know that behaves this way. We talked about it in derivatives before, because when we did y equals e to the x, I think we all learned that y prime is also equal to e to the x. But if I have y equals e to the 2x, y prime will have a derivative of 2e to the 2x because of the chain rule. Like, we take the original derivative and then derivative of the inside. And this right here absolutely matches this plan here. So we're going to find that e to the x and exponential growth and decay are absolutely intertwined. So let's just go into the problem set and practice a few of these and see where it goes.